let's continue on with the story problem. Now, even though this is a story problem, we're not going to let that concern us because it is a story problem in the section about greatest common factor. So chances are they want us to do greatest common factor here. All right, so it says that we have 120 red beads, 100 white beads, and 45 blue beads. And we want to use all the beads to make bracelets that have red, white, and blue beads on each. What is the greatest number of bracelets you can make? So, think about it here. They've given us three numbers, and the last sentence is a big indicator. What is the greatest number of bracelets we can make? Greatest number. So that means they want us to find the greatest common factor of those three numbers, obviously. So we're going to find the greatest number of bracelets you can make, 120 red beads, 100 white, and 45 blue. And they told us in the problem that each bracelet has to have the same number of red, white, and blue beads. So the answer is the greatest common factor of 120, 100, and 45. So here's the work. Now they decided once again to do the factor trees, the prime factorization here. All right, they did that for us. You can go through and vet their work if you want to, but they're showing 120 as 2 times 2 times 3 times 5. 100 is 2 times 2 times 5 times 5. And 45 is 3 times 3 times 5. Again, circle the numbers that are common to all of your rows. Well, this one's really easy because it's just that 1, 5. So when we pick a row and we say multiply, there's nothing to multiply. It's just the one circled number. So I picked the 120 row. There's a 5 there, which means the greatest common factor is 5. So that means in context of the question now, they're going to be able to make 5 bracelets. Now, follow-up down there then, they're talking about the equal part. Because you remember, they want nothing left over and they want to have the equal number of beads on each bracelet. So what they do to figure out these numbers that you're seeing here at the bottom is they take each of these numbers and divide by 5. So there was 120 red beads. If I divide those beads up among 5 bracelets, then there's 24 red bracelets, or 24 red beads on each bracelet. If there was 100 white ones, when I divide that up over the 5 bracelets, that means there's 20 white beads on each bracelet. And if I make 5 bracelets and divide the 45 blue beads up among all those bracelets, then there's 9 blue beads on each bracelet. Nothing left over, an equal number on each bracelet. Okay, so now let's see if we can make this a little bit simpler for us and learn a couple shortcuts here and there. All right, in number 1, they're asking us to find the greatest common factor of 14, 28, and 63. So you don't want to do quite as much work. You don't want to list the factors for everything. You don't want to make 3 factor trees. We can accommodate that. What you want to do is pick a number. It's in the question, so pick either 14, 28, or 63. And list all the factors for that number. So as you can see, I did that for 14. I came up with the 14 list as 1 and 14 and 2 and 7. Okay, so now what you're going to start doing is dividing. Start at the big end and divide out of the other numbers. And whenever you find the first number that goes into the other ones, that's going to be the greatest common factor. So for instance, I start with 14. Can I do 28 divided by 14? Yes, I can. But then when I try and do 63 divided by 14, the result is not a whole number. All right? So that means 14 is not the greatest common factor. So then we try 7. Can I do 28 divided by 7? Yes, I can. 28 divided by 7 is 4. Can I do 63 divided by 7? Yes, I can. 63 divided by 7 is 9. Since we've now shown that 7 goes into 14 and 28 and 63, that means that 7 has to be the greatest common factor. Now, usually the next question is, well, why did you start at the big end? Why didn't you start at the small end? Well, remember what the name of this is called. It's called greatest common factor. I'm looking for the biggest number that goes into everything. If I start on the small end, I'm going to have to test everything and then say, oh, the biggest one that goes in is this. But if I start on the big end, all right, if I start on the big end, the first number that works on that big end automatically has to be the greatest common factor. I don't have to test anything smaller because it couldn't be the greatest common factor. Now the other question would be, why did you pick 14? Well, truthfully, you can pick any of those numbers you wanted to do. All right, but chances are the smaller the number, the fewer factors it's going to have, which means less writing and less division when we're done. So you can pick any one of those numbers you would have wanted, but you might have a longer list of factors and then more things to test, and you would have still ended up with the same result of 7. All right, let's try that again on number 2. 360, 250, 170, and 40. So we could do the factor trees, but they decided to just list the factors of 40 here and then do the shortcut like we did in number 1. So for 40, we've got 1 and 40, because 1 times 40 is 40. 2 and 20, because 2 times 20 is 40. 4 and 10, because 4 times 10 is 40. And 5 and 8, because 5 times 8 is 40. So now I'm going to start dividing from the big end, take those numbers and divide them out of those front 3 guys. Remember, I don't have to do 40 because that's the number I've already got the answers for. That's what's already here. So if I go 40, does 40 divide out of 360? Yes, it does. 360 divided by 40 works. But when I try and do 250 divided by 40, that's where I run into problems. That result is not a whole number or an integer. So we go to 20. Does 20 go into 360? Yes, it does. Does 20 go into 250? No, it does not. That result is not an integer. So we go to 10. Does 10 go into 360? Yes, it does. Does 10 go into 250? Yes, it does. Does 10 go into 170? Yes, it does. Because 10 goes into all the numbers, that means 10 is the greatest common factor of 360, 250, 170, and 40. Okay, Nathan has made fishing flies that he plans to give away as gift sets. He has 24 wet flies and 18 dry flies. Using all of the flies, how many sets can he make? Okay, so again, we're not going to panic. Even though it's a story problem, it's in the section about greatest common factor. So chances are they want us to find the greatest common factor. That's a good deduction. There's 2 numbers there, 24 and 18, so we're probably finding the greatest common factor of 24 and 18. You'd be right again. So, as you can see, what they decided to do here is list the factors, and because these are relatively small numbers, they listed the factors of both. So for 24, you've got 1 and 24, because 1 times 24 is 24, 2 and 12, because 2 times 12 is 24, 3 and 8, because 3 times 8 is 24, and 4 and 6, because 4 times 6 is 24. For 18, they've got 1 and 18, because 1 times 18 is 18, 2 and 9, because 2 times 9 makes 18, and 3 and 6, because 3 times 6 is 18. Okay, remember, you're looking for the biggest number that's in both of the lists. All right, so let's pick this list. Is 18 on both lists? No. Is 9 on both lists? No. Is 6 on both lists? Yes, it is. All right, that means the greatest common factor is 6. That means that must also be the answer to the question. That means he's going to be able to make 6 sets of fishing flies. Now, I said to you how many of the wet flies would be in each set then. Well, there's 24 of the wet flies divided among the 6 sets would be 4 per set. If I said how many dry flies, well, there's 18 dry flies divided among the 6 sets. That would mean there's 3 per set.